black holes.
Black hole.
Black hole.
Black holes.
Black holes are real, they exist, we observe them all the time, and not only do they exist, they shape the universe that we live in.
Have you ever questioned whether there is more to life than meets the eye or whether we are truly alone in the universe? What happens if the James Webb Telescope ultimately establishes our existence within a black hole? Come along as we learn more about this mind-blowing, earth-shattering announcement that will cause you to re-evaluate everything you believe to be true about the cosmos. In the first place, what are black holes? They're frighteningly real. Although you may have seen them in science fiction films, the actual world is even worse than imagined. Some scientists claim that they are just black holes in space, but the reality is far more nuanced. In reality, black holes are enormous volumes of stuff compressed into extremely tiny spaces. Imagine a star 10 times as big as the Sun, condensed into a spherical the size of Manhattan. Nothing can withstand the gravitational pull of space, not even light. Ever since they began to consider objects in space that were so vast and dense that they might trap light, scientists have been enthralled with black holes. General relativity, the theory put out by Einstein, anticipated the most well-known theories regarding black holes. Essentially, a small, dense core is left behind after a large star dies. Everything is overpowered by gravity if the mass of the core is greater than 3 times that of the Sun. When you think about it, it's a very interesting and enigmatic occurrence, but it's also a little unsettling. So how are these black holes found by scientists? These objects don't release any light, so you can't merely aim your telescope at them and take a picture. In actuality, it is rather difficult to find black holes. However, scientists have discovered a means to make educated guesses about their existence by analyzing how they affect other adjacent matter. It all comes down to being aware of the cues. For example, accretion is the process by which a black hole draws matter to it from an interstellar cloud it passes through. But that's only the start. It's game over if a regular star gets too close to a black hole. As the material is drawn into the black hole, it can rip that star apart and release X-rays into space as it speeds and heats up. That's how indirect detection of black hole occurrence is possible for scientists. The most shocking thing, though, is that black holes drastically affect the communities that surround them. They have the ability to eat neighboring stars, release strong gamma-ray bursts, and even accelerate or halt the formation of new stars in specific regions. It's an enigmatic and startling occurrence that will definitely give you the chills. And from whence do they originate? Imagine this: stars that were once bright and brilliant finally explode in a stunning show known as a supernova. The fabled black hole, a mystery object, erupts from the remains of these fallen titans. Now, don't be misled by their name. These heavenly mysteries are not your typical holes. They eat everything that dares to approach them, much like the universe's version of vacuum cleaners. And you know what is really unsettling? Massive stars that have had a supernova explosion as their celestial retirement party give birth to the majority of black holes. It's as though their bright existence is coming to an end, leaving a gulf of unending blackness in its wake. The death state of smaller stars is known as neutron star transformation. Although they are extremely thick, light cannot be trapped by them. But if a star is a heavyweight champion, with a mass around 3 times that of our little Sun, then an astounding prospect emerges. It has been demonstrated by theoretical experts that there is no force in the universe that can stop this star from collapsing due to its own gravitational attraction. What a devastating fate that would be. Strange things begin to happen when this powerful star collapses. The star's surface approaches the event horizon and unseen line increasingly. This is when things start to become quite psychedelic. Time begins to deceive itself. When viewed from a distance, the event horizon appears to be where time slows down. Time seems to stop at that point when the surface contacts the event horizon, causing the star to collapse. It is as though the star's own clock runs faster than ours. Like an implosion that has frozen. Time frozen, quite eerie, don't you think? But well, what do you know? This story has an even more eerie twist. In the cosmic mosh pit, smaller black holes can occasionally collide and merge to become larger, more terrifying black holes. And just when you thought it could not get much uglier, consider the combination of a neutron star and a black hole. Their lethal dance creates an enormous nightmare, a horrifying thing beyond description. For years, scientists have had difficulty comprehending the magnitude of their own sizes. They seem to be the subject of a dark mystery that we are unable to solve. The truth is that there are two types of black holes, massive and little. The problem is that little is a relative concept. Relics from big stars, known as stellar mass black holes, can have a mass of up to 24 times that of the Sun. In the Milky Way alone, there may be between 10 million and a billion of them. There are an enormous number of black holes there, capable of consuming anything in their path. But there's still more. On the opposite extreme, supermassive black holes are millions or even billions of times bigger than the Sun. They are found at the core of massive galaxies, like the Milky Way. It's like a huge, black emptiness that is drawing everything in its direction. During his lifetime, famed scientist Stephen Hawking gave talks about black holes. Although the technology he needed to test some of his notions was lacking, his lectures were usually fascinating. But there is cause for optimism. Everything is changing due to a single scientific tool, and we are not prepared for it. It's here to explore the depths of our cosmos and goes by the name of the James Webb Space Telescope, or James Webb. We want to be clear, the James Webb is not your typical telescope. It's an engineering masterpiece that shows what the human spirit is capable of. Yes, we have launched other space telescopes in the past, and they have performed flawlessly. However, this bad guy is unmatched. The Hubble, which has faithfully served us for years, appears to be a small dot in the universe in comparison to the James Webb. And this cosmic marvel costs an astounding $10 billion. That's correct, there are enough zeros there to make your head spin. And get this, in addition to the priceless advice from more than 300 universities, the joint efforts of NASA, the European Space Agency, and the Canadian Space Agency were required to bring this miracle to reality. However, we must not overlook the dangers associated with such a large-scale project. This is definitely not a project for the weak of heart. The James Webb is exploring new ground, going beyond our current understanding, and visiting destinations we could only imagine. NASA recently revealed that the telescope has enough fuel to live more than double its minimum mission life expectancy of 10 years, following a successful launch. Numerous amazing accomplishments have been accomplished by the James Webb since its debut. It took it more than 1 million miles to get to its permanent home in orbit around the Sun. The telescope's enormous 5-layer sunscreen and enormous primary mirror, which had to be folded in order to fit on board the launch vehicle, were successfully unfurled during the voyage. Now that NASA has calibrated and adjusted it, the telescope is nearly prepared for full operation. The announcement by NASA that the James Webb Space Telescope had taken its first pictures of starlight was one of the most thrilling aspects of the telescope. The telescope's initial picture was of a star known as HD 84406, which produced a mosaic of 18 evenly spaced, brilliant spots from the star's light that were caught by the 18 mirror segments on the primary mirror. Afterwards, NASA unveiled an enhanced and refined picture of HD 84406, whereby 18 unfocused replicas of the star were consciously arranged in a hexagonal pattern. The observatory will start the image stacking procedure when it has correctly aligned each of the primary mirror's individual segments. This will stack 18 photos atop one another to create a single, crisp picture. The James Webb's advanced equipment will aid scientists in their exploration of the early phases of the cosmos following the Big Bang. It will investigate the events that took place during the epoch of reionization, which came about after the first stars created. This epoch describes the time when radiation from these early stars reionized neutral hydrogen, giving it an electric charge once more. Looking back billions of years is required for this, and a powerful telescope like the James Webb is the only tool that can do this. The telescope will also aid in the discovery of exoplanets, which are extremely hard to find due to their interactions with their host stars. Its potent sensors will be able to do more in-depth observations of these planets, which may include photographing their atmospheres in certain situations. Scientists may be able to more accurately forecast whether or not a planet is livable by having a better understanding of the planet's creation circumstances and atmospheres. In addition to examining how galaxies form, astronomers investigate galaxies to see the massive scale organization of matter. Thus, we are able to see the evolution of the cosmos. Over billions of years, the spiral and elliptical galaxies that we observe today changed from other forms. Examining the oldest galaxies to get a deeper understanding of their development is one of James Webb's objectives. Along with attempting to understand how we came to see the diversity of galaxies that we do, scientists are also attempting to understand how these galaxies now develop and assemble. Above all, though, the James Webb Space Telescope will enable us to address the most fundamental of questions: are we alone in the cosmos, or are we within a black hole? Additionally, James Webb has already begun searching. And you can probably guess what it discovered. 3 active galaxies have substances known as polycyclic aromatic hydrocarbons, PAHs, circling those huge supermassive black holes. These ring-shaped molecules made of carbon, known as PAHs, are the punk rock stars of the cosmos. From far-off galaxies to comets in our solar system, they may be found everywhere. Now, they're interesting not just because they could contain the elements needed to start life, but also because they aid in the tracking of star formation by astronomers. These PAHs become flamboyant and release infrared light when exposed to UV light. The mid-infrared instrument, MIRI, on board the James Webb can detect it, and typically that indicates the presence of some hot young stars nearby. Await the story twist, though. Ismael Garcia Burnett, our daring Oxford University astronomer, made the brave decision to look at 3 active galaxies, NGC 6552, NGC 7319, the eerily renowned Stephan's Quintet, and NGC 7469. These galaxies lie deep in the darkness, millions of light-years distant. The discovery Garcia Burnett made will cause your hair to stand on end right now. PAHs were abundant in the center regions where black holes rule supremely, according to MIRI. It sounds wonderful, doesn't it? The alarming part is that the radiation from those supermassive black holes warped the fundamental makeup of the PAHs. They became larger, more impartial versions of themselves as a result of it. The smaller, positively charged PAHs disappeared into thin air. Imagine being engulfed by the very blackness. There is, however, a ray of optimism. The reason the bigger PAHs survived is that they took refuge in gas-filled, thin, thick clouds. It's as though they have discovered their own shield from the dread of the black hole's fury. You may be wondering why this gloomy turn of events is relevant. Well, you see, astronomers who use PAHs to monitor star formation are faced with a bit of a dilemma. Electrically charged PAHs seem to be concentrated in star-forming areas. Tracking the birthplace of those stars becomes extremely difficult if the molecules are destroyed close to the black hole centers. But don't worry, our courageous astronomers aren't going to back down. Garcia Burnett intends to explore this dark cosmic chasm even farther with the group. The goal is to understand the mysteries of how these resilient PAHs manage to live in such terrible environments by analyzing additional active galaxies, each with a unique twist. They are looking at the unique characteristics of PAHs that may be hiding in the centers of galaxies that are home to black holes. This information is essential to comprehending star formation and the long-term evolution of these unsettling galaxies. The James Webb Space Telescope has revealed another astounding finding, though. Prepare yourselves for some really unsettling news. James Webb has discovered what may be the universe's earliest black hole. This celestial beast is a supermassive black hole, 10 million times heavier than the Sun. By examining tiny flashes of light that stretch back to the beginning of time itself, the James Webb was able to identify it. Situated at the center of a young galaxy, 570 million years after the universe's formation, lies this sinister and foreboding discovery. And here's the thing, astronomers think that much older black holes could exist elsewhere in space. Thinking about what more horrors could be out there, just waiting to be found, is both fascinating and horrifying. Undoubtedly, the James Webb Space Telescope is providing us with an unprecedented window into the deepest recesses of the cosmos, and the discoveries we're making are nothing short of astounding. The scientific community has been rocked by the finding of the universe's earliest black hole. This cosmic monster could just be one of several black holes that existed during the cosmic dawn, when the universe was just a billion years old and began to exist about 100 million years after the Big Bang. The sheer quantity of these black holes and their incredible growth leave astronomers perplexed. Despite publishing their results on the preprint website AR14, the researchers who made the most recent black hole discovery have not yet had their work peer-reviewed. Astrophysicist Rebecca Larson of the University of Texas at Austin, the study's lead author, thinks there may be a large number of undiscovered black holes out there. She said that we are now able to study cosmic history in a way that was previously unattainable thanks to the James Webb Space Telescope, and she is eager to see what more we will find. As we've already covered, black holes form when gigantic stars collapse and expand by engulfing everything in their path, including stars, gas, dust, and even other black holes. However, some black holes get so ravenous that the matter whirling about them warms up to the point where they begin to generate light that can be seen by telescopes. We refer them these as AGNs, or active galactic nuclei. Quasars, supermassive black holes that are trillions of times more massive than the Sun and release light bursts trillions of times brighter than the brightest stars, are the most extreme AGN. In order to obtain a sight of these elusive black holes, brave astronomers utilized the mid-infrared instrument, MIRI, and the near-infrared camera, NIRCam, two incredible infrared cameras. Equipped with these formidable weapons, they set out on a galactic expedition, surveying the heavens in pursuit of heavenly mysteries. It was more complicated than merely taking images, though. They had to solve the enigmas that were disguised by the light. That's where the integrated spectrographs in the cameras came in handy. They carefully dissected the light into its constituent frequencies like seasoned investigators, uncovering a wealth of data. Between the dim twinklings of the early cosmos, there was an unanticipated peak in the light's frequency spectrum. It resembled a warning sign that may indicate the existence of a black hole. They shivered as they realized that radiation was being emitted by the black hole's immense heat, faintly extending over the great expanse of space. The real mystery, however, was still how these black holes formed in the early stages of the cosmos so quickly. These astronomers' dreams were plagued by this question. They battled to find younger, hypothetical primordial black holes that may have formed immediately after, or possibly even before, the enormous explosion known as the Big Bang. However, despite their best efforts, these primordial black holes continued to be frustratingly elusive. How did black holes form and how did their incredible pace of expansion occur? Two dominant ideas with their own mysteries and shortcomings came to light. The first postulated that these black holes were the remains of huge stars, much larger than those that exist today. These extinct star giants would have developed at a speed that is incomprehensible to us, with a cosmic ballet between their birth and death. Although it was an enticing potential, time appeared to be the deciding issue. Because the cosmos was young, there had not been enough time for such a rapid process to take place. The second idea was as eerie but depicted the cosmos in a different way. It proposed that black holes, insatiable singularities of spacetime, were created when thick clouds of gas, towering like ominous specters, abruptly collapsed upon themselves. Although less plausible, this direct collapse scenario made sense given the quick creation, which called for a sizable volume of matter to fall straight into the center of darkness. The only limitation was time, as it always was, though it didn't seem like it in the early world. Another fascinating option surfaced when the researchers dug further into the vastness of knowledge. It had to do with the elusive population 3 stars, a legendary group of stars said to be the first in the universe. These stars, which are made entirely of hydrogen and helium, erupted early in the history of the universe. It was speculated that one such star had a catastrophic end, bursting in a dazzling display of cosmic fireworks. It left behind a black hole that was rabid, a cosmic devourer that was hiding in the shadows. However, this black hole was ravenous for evil. It grew at an extraordinary rate, dangerously consuming large amounts of surrounding stuff. It eagerly grew beyond expectations, defying stability. The researchers were perplexed by this peculiar behavior, which led to further inquiries regarding the cosmic forces at work. Unfazed by the cosmic mysteries around them, the researchers teamed up with MIRI's creators to form a potent coalition in their quest for solutions. Together, they set out on a brand new expedition to search for a stronger signal of the elusive light among those emissions by searching far-off galaxies. They weren't satisfied with merely catching glances. Their goal was to unearth well-kept mysteries, a mysterious code that would solve the mystery of the black hole that sat in the heart of the old galaxy. We have no idea what is in wait for us to uncover in the vastness of the cosmos. But the James Webb Space Telescope, our jaw-dropping telescope, is not done exploring yet. The top cosmic investigator has made an astounding discovery. And here's the kicker, it has found not one, not two, but an astounding 6 massive old galaxies that have been dubbed universe breakers. Because they contradict all we now understand about the universe and have the potential to completely upend accepted cosmological ideas. Imagine that these magnificent galaxies are remnants of a time when the cosmos was only 3% of what it is now. The shocking thing is that they are quite large. We are discussing galaxies so massive that they dwarf the Milky Way, which is our own galaxy, in size. At a point in the cosmic chronology when scientists were expected to find little more than pint-sized infant galaxies, these universe breakers are strutting their stuff. But wait, these galaxies aren't just cosmic toddlers, they're fully grown adults living in a celestial playground. So how did these celestial giants come to be discovered by the James Webb Telescope? It combed through the old light released by stars and galaxies with its astounding infrared sensor equipment. You know what grabbed their interest, though? A bewildering deep red light emanating from a collection of hazy, blazingly brilliant specks. In the untamed field of astronomy, redness is an age indicator. The cosmos is expanding, stretching and redshifting light as it travels through it. You'll be shocked to learn how old these galaxies were. They emerged only 500 to 700 million years after the Big Bang, giving them an astounding age of 13.5 billion years. Even while the oldest galaxies previously seen by the James Webb Telescope were spectacular, at 350 million years old, they had nothing on these enormous cosmic children. The immense bulk of the recently discovered universe breakers made them look insignificant. These mind-bending galaxies have mass equivalent to tens to hundreds of billions of sun-sized stars. They are truly a match for the Milky Way, akin to celestial superstars. All of our preconceived notions about how galaxies form are called into question by the presence of these cosmic monsters. It seriously tampers with the foundations of our existing cosmological theories. It makes us re-evaluate the basic tenets of our theory on the formation of the earliest galaxies. Is it necessary to discard the cosmological rules or revise our theories on the formation of such young galaxies from small star and dust clouds? Imagine if the cosmos was meant to cool down slowly over hundreds of millions of years following a period of tremendous expansion, enabling gas to come together and create the first stars and galaxies. But wait, these massive galaxies imply that the gloomy ages, the period of time thought to have been a cosmic nap, might not have been as gloomy as previously thought. The cosmos appears to have punched the cosmic snooze button, causing star creation to explode into an incredible fireworks show much sooner than we could have ever predicted. Of course, further proof is required to properly validate this astounding discovery. The daring group of scientists behind this cosmic bombshell want to collect further data. Their goal is to obtain spectrum photos that will allow them to calculate the mass and precise distance of these extinct giants. Then and only then will we be able to determine if these universe breakers are genuine or whether we have discovered something much more astounding. However, if this wild discovery proves to be accurate, it will rock the scientific establishment and completely alter cosmology textbooks. In addition to the incomprehensible, who knows what other mind-bending cosmic shocks lie in wait for us in the vastness of space? The James Webb Space Telescope is on a quest to discover. We are getting closer to discovering the shocking and sinister truths hidden within the cosmos, which is full of riddles just waiting to be solved with every new finding. Did you enjoy this video? Please like and comment below. Turn on the notification bell to get notifications for videos like this.